Welcome to the another session in Frontiers in CFD. CFD simulation of hybrid cooling, PCM plus liquid for lithium-ion battery pack. Today's objective is to create 3D geometry of lithium-ion battery pack with PCM to generate mesh, apply name selection on computational domain, to set up the simulation and visualize the liquid fraction, cell temperature and total temperature of system. Welcome you all. Today we will see the CFD simulation of lithium-ion battery with hybrid cooling system using PCM and liquid. So let's start with workbench window. So we'll use ANSYS Fluent. The geometry we will prepare with the ANSYS design modeler. So the first step will be to prepare geometry. Okay, you can see now. Use the fluid flow fluent. Click on geometry. Click on new design modeler geometry. So the dimensions that we are going to follow. So I'll do it one by one. So first of all, set the units to millimeter. Observe the coordinates x, y, z. X is your red, y is your green, and z is your blue. Click on any one of the plane. So go to the create and primitive. That is a box. So make it add to frozen. Dimension in x component I will take 80. Dimension in z component I will take 80. Y component I will take it 65. And let's make it generate. So this is the box we have generated in x direction. Now I will create one more sketch in zx plane. So create a circle here. Dimensions of this circle will be equal to 18. From one end, this distance will be equal to 16. So let's take it 16. Similarly from top also I need 16. So put that value is equal to 16. Next we need to draw a line to draw the second cell. So they will be separated by a distance that is 24. Another line we have to draw. So this will be separated by distance that is equal to 24. So just draw. You can directly copy also. So one more line we are drawing at a distance of 24, and one more last line we will require, that too at a distance of 24 from here to here. So specify the dimensions that is equal to 24. Now click on copy, select here, set paste handle. I will do it again. Copy, set paste handle. Click on end. Select all these three. Click on copy. Select at the second location, similarly at the third location. So we have drawn 3 circles. Now this is your cell geometry. So click on extrude. Instead of add material, we'll select it add to slice material. Depth I will take it 65. That is equal to the height of the cell. Okay, ensure that this is removed. So go and modify. Just check if at some place you have additional things, or just trim it out the line which are not required. So now go with the same operation again. Click on edit, make it not geometry, select XY, and then you can see now all they are separated out. Now we have generated the cells. We need to generate the pipe channel. So for this we need to prepare one more sketch. So click on sketch 2. So for this I will draw a circle from the same center which we already had. So dimensions of that circle will be equal to 24, diameter is 24. Then draw a line from this going towards your circle, and let's take it to one end. Similarly at the bottom you need to draw towards the circle. Take it here. One more circle you have to draw from this. Then one more line you will have to draw up to this. Take a line here. Then one more circle you have to draw. So once the circle is drawn, you have to draw a line. Take it to the point and just reach at the other end. Now you have to trim out the unnecessary things which are not required. So this is not part of the circle which is required. So trim it out, the one which is not necessary. So we have generated the path. Once you have to check the path and then you can proceed. So the path is also generated. Now I need to create a channels. So to create the channels I need to take another face. So simply visualize this particular face. So this will be your YZ plane. So on YZ plane I can prepare sketch. So click on circle, slightly zoom in. So this is the dimension of circle I have to take. So diameter I will take 5. Let's take the distance from one end to here. So the distance which we want to take, say around 4 here. Then from top also we need to take distance. This distance will be equal to 10. So draw one more line from here. So the distance is now here will be equal to 15. Similarly I need to get the second and third. One more line you have to draw horizontally. Take the distance that is equal to 15. One more line you have to draw. Take the distance that is equal to 15. Take the dimensions, make it 15. Now draw the circles which we have already. You may directly use copy option. set paste handle at second, third, and lastly at 4. Click on end. In this way we have prepared the path. You may just trim out the unnecessary things which are not required. So we have all circles now. So click on sweep operation, click on sketch 3, and path will be your sketch 2. Instead of add material, make it slice material. If everything is right, you will get the curve and channel generated. You can see channels are generated properly. Now you can see the channels are generated. So now what we will do, we'll add one more sketch in YZ plane. So that will show you internal diameter. So specify the diameter of this. So that is equal to 4. Similarly, I need all other circles. You can click on copy, set paste handle from all locations and create all 4. Then one more time you can click on sweep operation. Sketch 4 will be the profile now and sketch 2 will be path. One more time generate. So now you can see internal channels will also be getting generated. So in this way we have prepared the geometry. Now while doing so, we need to separate out the things. So select all cells. Then form new part. So you can define that part as cell. Now select, this will be your PCM. Let's see the channels now. So this will be your channels. Sorry, this will be your pipe. Now this will be your fluid. So define as a fluid. So this is your PCM, cell, pipe, and lastly it is your fluid. So one by one, just check it out. For cells, you need to give the names to cell all at all places. Make it cell here also. And lastly cell. Then for pipe, you may specify all names as a pipe wherever it is required. and lastly your fluid. So click on copy, and for all you have to keep as a fluid. In the definition also you need to change this to fluid. In definition right now you are observing solid, so let's make it fluid and click on generate. So this is your PCM. Now so in this way the geometries are been prepared. Now we need to prepare some void spaces at the top. So again we will follow the same approach which we followed earlier. So in ZX plane I will create one more sketch, say sketch 5, draw a circle. I will select all bodies, and I will hide all bodies. So we left with sketch only. So now give the dimensions for your sketch. So we'll give it around 10. I'll just check once. Give the dimensions from one end. So we'll give it around 28 from one side. Similarly 28 from the top side. We'll put that value. If you want you can modify the diameter. We have taken 10. You can, if you want you can take 12 as well. So similarly I will draw one more sketch which is from here to here. Dimensions of that sketch will be again 24. So one more circle which we can draw here. So let's click on copy. Same circle we need to copy at this location. Click on end, then select the two circle, copy, and set the paste handle and connect it here. So in this way we have generated four more circles. So I will say show all bodies. Now I will use the extrude operation. So sketch 5, instead of add material I will make it slice material and then generate. So you can see now this is the separate part which has been generated. We need to trim out this part. So let's click on create, body delete, select the two bodies, all four bodies, sorry, and let's click on delete here. So what you can see is the white spaces now. Let's visualize like this. Now we just need to modify something. Let's hide this part and we'll hide the cell as well. So we're left with now the sketches. So first of all you may select the all outer sketches which are in here. So that will give you the pipe structure. So create boolean, make it apply and generate. Now you can hide all these bodies and you can just now go with the fluid part. So you can select all and create the boolean operation, make it apply and generate. So we have cells, we have PCM now, we have pipe, we have fluid, and we also have some void spaces. So click on show all bodies. So in this way this geometry has been prepared. Additionally, if you want to remove some material from here, that can also be removed by preparing a kind of sketch here, and by that way it can be done, but we are not going to do this, so I will just go with this. So before proceeding for the next step, let's click on to save the work. So create a new folder. I will specify as hybrid battery thermal management system. So let's put it hybrid battery thermal management system. So once you are saved, you can proceed for the next step. Now we are done with the geometry. Let's proceed to the next part of mesh. Click on edit. Sometime if you show this error, you close the window and open it again. So let's one more time open the mesh part. Click on edit. Now we are not required the geometry. You can turn it off. Ensure that the fluid zones are properly specified, and there are some 5 zones which are properly specified. If they are correct, then there will not be any issue with solving the example. So let's proceed with the mesh part. Now you can see the geometry has opened here. So let's click on generate mesh. This will be the default mesh that is going to be generated, but default may not work as it may not have sufficient number of nodes and elements which are been properly distributed. So we might have to modify the geometry. So accordingly we'll check out what can be done. So you can see this is how the mesh is been generated as of now. Let's see the count. So we'll just take it 0.005 first, or 0.001, and let's make it generate. So we may want to keep this value within the student version of ANSYS, so that if it is to be there, it should be below 10 lakh number of nodes and element. If geometry is not required, you may just close the geometry. So let's wait for the mesh to complete. So you can see now the mesh has been generated here. See the count, it is around 10 lakh 5642. You may go with 00075 as a count and you can generate the mesh. So this will be slightly on the finer side, but time requirement will be more. We'll just check it out how good the mesh is, otherwise we'll go back to the previous one. Definitely the time requirement here will be more for the simulation. So it is taking time. Let's see how much is the count, and then we'll, if it does take more time, we'll come back to the earlier stage. So this looks to be quite fine. Let's see, 16 lakh 58,000. So this looks to be slightly on the higher side, but you can okay, we'll go with the 001 and make it update. So the count is around, I think, 10 lakh for this case. So if you're getting the floating point exception error, you can come here in this from the setup, and then you can modify and you can run it again. So we'll just check out with this current count, which whether it is suitable for us or not, whether we are able to run the simulation or not. If it works, then there is no issue. So this is the count which we are getting right now. It is around 10 lakh, and this is 22 lakhs as the number of elements. So the mesh translation to fluent has been successful. You just have to specify the inlet outlets. So specify inlets and outlet. So these are my all inlets. So we'll specify this is, similarly we'll specify this as outlet. So this is your inlet, second one is your outlet. Now go to the geometry, select on cell. I will say hide all other bodies. So select all. I will specify this as cell boundary. So this is inlet, outlet, this is cell boundary. I will say show all bodies, and now let's say PCM. I will say hide all other bodies. One more time I will select all and create name selection as PCM boundary. So we are done. So let's make it show all bodies. This is inlet, outlet, cell boundary, PCM boundary. One more time, just click on update. So you can see the mesh translation to Fluent successful. You can close the window and proceed further. So let's click on setup. So double precision, put the number of processes you can run. Let it be 16 and go ahead. So till the time the geometry is loaded, we have to wait. So the geometry is loaded. You can see some inlet outlets have also been available. Select transient, select gravity, put it minus 9.81. Then go to the model, turn the energy equation on, make it okay. Go to viscous, select K epsilon, enhance wall treatment, thermal effect, curvature correction, and make it okay. Then in solidification melting, turn it on, make it okay. Click on OK. Then in materials, so first of all we'll define PCM liquid. So let us say PCM liquid. So we might need the properties of PCM. So for paraffin wax liquid, density is 790, specific heat is 2150, thermal conductivity is 0.22, viscosity is 0.01, then pure solvent melting heat 240800, solidus temperature 313.6, liquidus temperature 317.7. So make it change create and click on OK. Then you need PCM fluid, water liquid as a fluid. Make it copy and then close. So here we will just define lithium battery first. So the properties of lithium battery I need to put. Click on change create, OK. Then go to this again, add solid from the database. I put it this one, click on close. One more time, now we have to define PCM solid. Click on tab PCM solid. Define the properties of PCM solid. 800, then 2000. Thermal conductivity will space is 0.2. Make it change create and OK. One more time, just go here, take solid, copy aluminum, close. So aluminum will be for channel, PCM solid and liquid that will be available, and lithium battery. Go to the cell zone condition, select zone type, PCM you have to transform, let us say, to fluid now. So ensure that PCM liquid is present. Click on apply, close. For fluid, ensure that water liquid has been present. If not, make it change. Now go to the cell, ensure lithium battery, click on source term, click on edit. So use the value of heat generation rate. So I use 104017 as a heat generation rate. Make it OK, make it apply and then click on close. For pipe, ensure that this is aluminum, make it apply, then close. Go to the boundary condition. At inlet I will specify velocity, that is 0.25 meter per second. Make it apply and then close. Ensure in cell boundary contact region all the regions are cell, material, lithium battery. If it is there, then there is no issue. Then for PCM you might have to change it here, as the default material may not show PCM. So I just go with PCM solid here, make it apply. So you have to do it all location. Make it apply, make it apply, make it apply. Here also you have to do the same. Click on PCM, go to thermal, PCM solid, make it apply, make it apply, close, make it apply, close. Select this, click on edit, thermal, let us say PCM solid, make it apply, close, make it apply, close. So for all region you have to do the same. Instead of lithium battery you have to select PCM material. By the way, the PCM is paraffin wax. click on edit, go to thermal, say PCM solid, make it apply, then close, make it apply, close, click on edit, thermal, PCM solid, make it apply, close, make it apply, close, click on edit. You have to select the material. So let's say PCM solid, make it apply, close, make it apply, close. So at wherever the places you are observing PCM, you have to change that material to PCM solid. Make it apply at all the places where you will see that. Okay, the last one is left. Click on edit, click on PCM solid, make it apply, and then close. Now we are done it for PCM. One more thing is left, just check it out. Select the PCM solid here. Once this is done, make it apply and then click on close. Ensure that wall pipe, the material is also pipe metal, so make it apply and then close. Now go to your report definition. I select surface report area weighted average, select temperature, I select total temperature, select all. I put here system temperature. So print to console and create output parameter. Similarly, surface report area weighted average, temperature, total temperature. I will select now cell. So select cell temperature curve, make it OK. One more time, surface report area weighted average. I will select solidification melting, liquid fraction on PCM now. So wherever you are observing PCM region, you can select all this PCM region in order to calculate the liquid fraction in that region. Print to console. PCM fraction liquid, make it OK. If you want, you can click surface report area weighted average. You can select temperature, the total temperature at outlet. I'll say temperature at outlet report definition. So let's make it OK. Now proceed to the next step. Click on initialization. Click on initialize. Once it is initialized, you have to go to the calculation activities and you need to set the animations. So if you are running the simulation for a long time, it is recommended to click on autosave. Go to solution animation, click on new object contours, select temperature, select total temperature, select all, go to float, make it apply, close, click on save display, click on close. I will put system temperature animation, make it OK. One more time, click on contours, temperature, total temperature of cell. So select all cells, click on apply, then close, click on apply, close. Second one is your cell temperature animation, make it okay. One more time, go here, contours. Now I'll select solidification melting. So you need to select all PCM region. So instead of exponential, I will make it float, make it apply, and then close. Let's say close this window. Animation, liquid fraction. Once go and check with the PCM liquid fraction. You have selected all. Yeah, it is selected all. For cell temperature also, just check. Okay, so here we have not selected one of the region. So that is cell boundary, that you need to modify and make it okay. Just check it once. Yeah, now you can click on run calculate and start doing the calculations. So let's click on calculate. So depending on the mesh count which you have selected, the time requirement will be more or less. So if you are getting the floating point exception error, you have to go back and change the mesh size. So once first 20 iterations are completed, the all console windows will be visible. Whatever the temperature at outlet report, PCM liquid fraction, cell temperature curve, total temperature system curve. Then along with that we had some animation as well. So all these animations which we are set will now be visible once first 20 iterations are been completed. So we'll have to wait for some time and then we'll check out what are the results. So depend on the count which you have selected, the time requirement here will be more. Okay, you can see now and the process just now has started. So definitely it will take some long time. Still our count is comparatively on the lower side. So once this 8765432 are completed, you will be able to see all windows that will appear along with the scale residual. Some other windows will also be visible that we have set in report definition as well as those we have set in animation. So once this are completed, we'll be able to visualize that. So 3 2 now There will be one more, and now the windows will be visible one by one. You can see now the windows are getting visible. So this may take some time, as you can see. So this is your scale residual. This is the total system temperature. This is the cell temperature curve. This is liquid fraction curve, initially showing 0. After some time this will go up. This is your total temperature at outlet, liquid fraction animation. This is your cell temperature animation, and this is your total temperature system animation. So we'll wait for some time and then we'll come back. So we have completed around 10 time steps now. Just visualize for the initial stage. You can see all these curves and other thing. And this is your cell temperature, total temperature, and this is your cell temperature. Liquid fraction is not available as of now. Just click on save button, and then we have to run it further for a long time in order to visualize all the liquid fraction and other thing. So we'll run it further and then we'll come back. Saving the work is done. Now we can click on calculate one more time. So again we have to wait for some time to visualize it as for the liquid fraction and other thing. So we'll run it for around 100-200 seconds and then we'll visualize. So we are on the simulation for around 2 seconds. You can see here 220 seconds. So this will represent the cell temperature which is rising. This is your so liquid fraction is not available as of now, as it has not reached to the melting point. So this temperature starts is going increasing. So after some time the curve is likely to get flat. So we'll wait till the time we are observing the liquid fraction. We need to run it further. The calculation is completed. You can see the simulation is around 600 seconds. You can see the contours of total temperature for cell. These are the liquid fraction which is not available as of now. This is the contours of total temperature of system. This is the temperature at outlet of the system. Liquid fraction not available as of now. Cell temperature report definition. This is your system temperature report definition. So I need to run this again for further so that we can visualize the solidification and melting. So let's save the work and run the simulation again. The simulation is completed for around 1300 seconds. You can see the time here. The calculation is completed. Now you can let's start from the scale residual. Then this is your system temperature curve. Temperature has reached to around 305. Then total temperature of cell, the temperature has reached around 310. You can see the PCM liquid fraction which is the now visible. Then we have the temperature at the outlet. This is the liquid fraction, still not much visible, but it may take some time. Then this is the total temperature on the cell. So you can see some of the cells are subjected to higher temperature, some of them are lower. Now we need to run this further in order to visualize the liquid fraction which is not that clearly visible. So we'll run this simulation further maybe around 200 or 300 times so that this value will be slightly significant, and then we can visualize this liquid fraction present here also. So one more time, just click on save and run the simulation further. So let's come here and click on calculate one more time. Next 100 iterations are also completed. You can see here now total is 1400. This is again cell temperature. You can see slightly they are visible with liquefaction. Here you can see. So I have to run this further in order to visualize it more proper way. So we'll run it further and we'll continue with the calculations. Click on save button to proceed for the further step. So start with the calculation again. We have completed the simulation for around 3000 seconds. Now you can see system temperature, the curve become flat. Total temperature of cell also become flat. PCM liquid fraction, it is gradually increasing, but the rate is quite slow. So the cell temperature by observation indicates that it may not increase further. So the total temperature at outlet, so you can see the liquid fraction is present here. So if you heat further or if you continue to go on heating further, we may observe some slight changes over here. And lastly, this is how your total temperature system, and this is your cell temperature. So you can see some of the cells are green, some of the cells are red, hot. So depending on the position of fluid as well as on the PCM, the things are changing. You can see the liquid fraction of PCM with respect to flow time. So we are run it up to 3000 seconds. You can see the curve is rising. This represents cell temperature with respect to flow time. The cell temperature curve becomes flat over the period of time. After 1000 we observe the flatness, and it almost becomes flat after 1500. This represents the total temperature of system with respect to flow time. Again the curve becomes flat, meaning no further changes in temperature will happen.